Hello everyone, myself Michael Ravina, Associate Professor, Department of Computer Science and Engineering. The subject is CS 3551 Distributed Computing. The unit is Logical Time and Global State. Today we are going to discuss about asynchronous execution with synchronous communication, synchronous program order on asynchronous system, and group communication. Asynchronous execution with synchronous communication. When all the communication between pairs of processes is by using synchronous send and receive primitives, the resulting order is synchronous order. The algorithms run on asynchronous system will not work in synchronous system, and vice versa is also true. Here there are an asynchronous execution that is realizable under synchronous communication is realizable with synchronous communication, that is the RSC execution. An execution can be modeled to give a total order that extends the partial order. This is the representation. The first figure represents the execution of deadlocks when using synchronous primitives. Deadlock means more than one process occurring or sending or receiving the messages at the same time on the same resource. Then next one is the illustration of the non-RSC, that means the realizable with synchronous communication with asynchronous executions. RSC, that means non-separated linear extension, is an extension of E, precedes, that means precedes simple, such that for each pair S, R belongs T, the interval X belongs to E, that is the S precedes with X precedes with R. That means before the event R, the S will be executed, is empty. Then next one is the RSC execution. And asynchronous execution E, precedes is an RSC execution if and only if there exists a non-separated linear extensions of the partial order of E, precedes. Then next one is the crown. Let E be an execution. A crown of size K is in E is the sequence. That will be S, I, R, J. Then that is I belongs to 0 to K minus 1 of pairs corresponding to send and receive events, such that S0 proceeds with R1. Likewise, S1 proceeds with R2. Okay, this figure illustrates the non-RSC asynchronous executions and crowns. First, the crown is in A part, the crown is S1, R1, S2, R2. We have S1 proceeds with R2 and S2 proceeds with R1. The next part B is the crown is S1, R1, S2, R2. We have S1 proceeds with R2 and S2 proceeds with R1. The next part is the Z is the crown. Here S1, R1, S3, R3, S2, R2. We have S1 proceeds with R3 and S3 proceeds with R2 and S2 proceeds with R1. The crown test for the realizable synchronous executions. There are three different steps. First one is to define the that means T cross T relation on messages, that is T is totally ordered with the ordered set. Here we consider the above conditions, three conditions. First condition is four conditions. There are four conditions. First, S proceeds with Sj or S proceeds with Rj, or R proceeds with Sj, or R proceeds with Rj. Now we define a directed graph, that is G equal to T comma tends to, where the vertex set is a set of messages T and the edge set is defined as the arrows. Next, observe from the definition of crown that graph has a directed cycle if and only if E comma proceeds has a crown. Then crown criterion, an asynchronous computation is RSC, that is it can be realized on a system with synchronous communication if and only if it contains no crown. The crown test complexity is order of E, actually as communication events. Timestamp for a particular RSC execution is execution E comma proceeds is a RSC if and only if there exists a mapping from E to T such that for any message M comma T of S of M equal to T of R of M. Synchronous program order on asynchronous system. Here first deterministic program. Synchronous program order for a repeated runs produce the same partial order. This means deterministic receive tends to deterministic execution tends to E comma E is the execution, that means E comma the particular proceeds is a fixer, non-determinism. Then next one is a receive call does not specify the center. Then multiple sends and receives enabled as a process and can be executed in an interchangeable order. Deadlock example is described in the following big figure. If an event order is a process is permitted, no deadlock. How to schedule the synchronous communication calls over the synchronous system? Match send or receive with the corresponding event. Next, binary Rendezvous, that means implementation using token for each enable interaction, then schedule online automatically in a distributed manner. The Rendezvous systems are a form of synchronous communication among an arbitrary number of asynchronous processes. All the processes are involved meet with each other, that is communicate synchronously with each other at one time. There are two types of Rendezvous system. First one is a binary, then second one is a multi-way. This is a background algorithm for binary Rendezvous code. First, we describe about message types, that is M, acknowledgement of particular message, request of message, then permission of message are described. Then after that, PI wants to execute send of M to a lower priority process PJ. Then next step is the PI want to execute send of message to the higher priority process. Suppose the PI want to execute send of message to the particular lower priority means then PI executes and blocks until it receives acknowledgement from PJ. So suppose if it is a higher priority process means PI seeks permission from PJ by executing send of request M. When PI is waiting for a permission, it remains unblocked. If a message M arrives from a higher priority process, PI accepts the message and scheduling a receive of M dash event, then execute the particular send of acknowledgements. If the request of message arrives from a lower priority means, then the PI executes send the permission to particular process and blocks waiting for the message. When M arrives, the receive message event is executed. When the permission arrives, PI knows the partner PJ is synchronous and PJ executes the particular send of M. And then next step is a send request of message arrival at PI from a lower priority means Then at a time of request message processed by the page, it executes the sent off message and blocks the waiting for the message M. When the M arrives, the receive of M event executed and the process unblocks. Then message M arrives at PI from a higher priority process. At the time of message M processed by the PI, the process PI executes the receive of M. Then processing when PI is unblocked. When PI is unblocked, it dequeues the next and the message from the queue and processes it as a message arrival. The next one is the group communication. Group communication can be done by broadcasting messages. A message broadcast is the sending of message to all members in a distributed system. The communication may be multicast and unicasting. Multicast means a message is sent to a certain subset or a group. Unicast means a point-to-point message communication. The network layer protocol cannot provide the following functionalities. First one is the application specific ordering semantics. The next one is adapting groups to dynamically changing membership. Then next one is the sending multicast to an arbitrary set of processes at each send event. Then next one is the providing various fault tolerant semantics. The next one is the multicast algorithms can be open or closed group. Then these are the differences between closed and open group algorithm. Closed group algorithms mean if a sender is also one of the receiver in the multicast algorithm, then it is a closed group algorithm. Open group algorithm means if the sender is not a part of the communication group, then it is the open group algorithm. In the closed group algorithm, they are specific and easy to implement. Comparing with closed group, the open group algorithms are more general, difficult to design and expensive. In the closed group algorithm, it does not support large system where client processes have short life. In the open group algorithms, it can support large systems.